Paralleling conductors is a common practice in electrical distribution systems to increase the current carrying capacity of a circuit. By paralleling conductors, the total cross-sectional area of the conductors is increased, which in turn reduces the resistance of the circuit and allows for a higher current flow. There are several factors to consider when paralleling conductors, including conductor size. The size of the conductors used for paralleling should be the same size as the existing conductors. Using conductors of different sizes will result in uneven current distribution, which can lead to overheating and premature failure of the smaller conductors. Another factor is the number of conductors. The number of conductors used for paralleling should be determined based on the desired current carrying capacity. The more conductors that are paralleled, the higher the current carrying capacity. Conductor spacing is also an important factor. The conductors used for paralleling should be spaced apart to allow for proper heat dissipation. The spacing between conductors should be in accordance with the manufacturer's recommendations. Paralleling conductors can be a cost-effective way to increase the current carrying capacity of a circuit. However, it is important to carefully consider the factors discussed above to ensure that the paralleling is done correctly. In addition to the factors discussed above, there are several other considerations that should be taken into account when paralleling conductors. One consideration is the skin effect. The skin effect is a phenomenon that causes the current to flow primarily on the outer surface of a conductor. This can lead to uneven current distribution in paralleled conductors, especially at high frequencies. To minimize the skin effect, the conductors used for paralleling should be stranded. Another consideration is the proximity effect. The proximity effect is a phenomenon that causes the current in one conductor to induce a current in an adjacent conductor. This can lead to uneven current distribution in paralleled conductors. To minimize the proximity effect, the conductors used for paralleling should be twisted or transposed. Thermal expansion is another consideration. Conductors expand when they are heated. This can lead to increased spacing between conductors, which can reduce the current carrying capacity of the circuit. To compensate for thermal expansion, the conductors used for paralleling should be secured with expansion fittings. Paralleling conductors is a common practice in electrical distribution systems to increase the current carrying capacity of a circuit. However, it is important to carefully consider the factors discussed above to ensure that the paralleling is done correctly. By following these guidelines, you can ensure that your paralleled conductors will provide reliable service for many years to come. When paralleling conductors, it is crucial to adhere to the National Electrical Code, or NEC, guidelines. The NEC specifies requirements for conductor size, opacity, insulation type, and termination methods. These regulations ensure safety and prevent overheating or damage to the electrical system. Always consult the latest edition of the NEC for specific requirements applicable to your installation. Proper termination of paralleled conductors is essential for reliable performance. Use appropriately sized connectors and ensure that all connections are clean and tight. Avoid mixing different types of connectors, as this can lead to corrosion and increased resistance. Consider using compression connectors, which provide a more secure and reliable connection than screw-type connectors. Regularly inspect connections for signs of looseness or corrosion and tighten or replace them as needed. When selecting conductors for paralleling, choose those with the appropriate insulation type for the environment in which they will be installed. Factors to consider include temperature, moisture, and exposure to chemicals or sunlight. Common insulation types include THHN, THWN, and XHHW. Refer to the NEC for specific insulation requirements based on the application. Ensure that the conductors are properly supported to prevent sagging or strain on the terminations. Use cable ties, straps, or other suitable supports to secure the conductors at regular intervals. Avoid sharp bends in the conductors, as this can damage the insulation and reduce the current carrying capacity. When paralleling conductors in a conduit, ensure that the conduit is properly sized to accommodate all of the conductors. The NEC specifies the maximum number of conductors that can be installed in a conduit of a given size. Overfilling a conduit can lead to overheating and damage to the conductors. Consider using larger conduits or multiple conduits to provide adequate space for the conductors. When designing a system with paralleled conductors, perform a thorough load calculation to determine the required current carrying capacity. Factor in all anticipated loads, including lighting, equipment, and appliances. Use the NEC capacity tables to select the appropriate conductor size based on the calculated load. Consider future load growth when determining the required current carrying capacity. Ensure that the overcurrent protection devices, such as circuit breakers or fuses, are properly sized to protect the paralleled conductors. The overcurrent protection devices should be sized no larger than the ampacity of the conductors. Refer to the NEC for specific overcurrent protection requirements. Regularly inspect the electrical system for signs of overheating, such as discolored insulation or melted connectors. Use a thermal imaging camera to identify hot spots in the system. If overheating is detected, investigate the cause and take corrective action immediately. This may involve replacing damaged conductors or connectors, or adjusting the load on the circuit. When working with paralleled conductors, always follow safe electrical work practices. To energize the circuit before working on it, and use appropriate personal protective equipment such as insulated gloves and safety glasses. Never work on live electrical circuits unless you are qualified to do so. Consider using a qualified electrician to install and maintain parallel conductor systems. A qualified electrician has the knowledge and experience to ensure that the system is installed and maintained properly and that it meets all applicable codes and standards. In addition to the NEC, there are other standards and guidelines that may be applicable to parallel conductor systems. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Electrical Manufacturers Association, or NEMA. Consult these standards for additional guidance on the design, installation, and maintenance of paralleled conductor systems. The skin effect, mentioned earlier, becomes more pronounced at higher frequencies. In alternating current, or AC, circuits, the current tends to flow more on the surface of the conductor as the frequency increases. This reduces the effective cross-sectional area of the conductor, which increases its resistance and reduces its current carrying capacity. To mitigate the skin effect, use larger conductors or conductors with a larger surface area, such as hollow conductors. The proximity effect, also mentioned earlier, occurs when conductors are located close to each other. The magnetic field produced by one conductor induces a voltage in the adjacent conductor, which causes current to flow in the opposite direction. This increases the current density in the sides of the conductors that are closest to each other, which can lead to overheating. To mitigate the proximity effect, increase the spacing between conductors or use conductors with a larger surface area. Transposing conductors, as mentioned before, is another way to reduce the proximity effect. Transposing involves periodically switching the positions of the conductors in the circuit. This ensures that each conductor experiences the same average magnetic field, which reduces the uneven current distribution. Consider using bundled conductors, which consist of multiple conductors that are twisted together. Bundled conductors have a larger surface area than single conductors of the same cross-sectional area, which reduces the skin effect and proximity effect. Bundled conductors are also easier to install and terminate than multiple single conductors. When paralleling conductors in a three-phase system, ensure that the conductors for each phase are properly identified and grouped together. Use color-coded conductors or cable markers to identify the phases. This will help to prevent phase imbalances, which can lead to overheating and reduced efficiency. Phase imbalances can occur when the loads on each phase are not equal. This can be caused by uneven distribution of lighting, equipment, or appliances. To minimize phase imbalances, distribute the loads evenly across the phases. Use a three-phase power analyzer to monitor the current and voltage on each phase. This will help you to identify and correct any phase imbalances. When paralleling conductors in a direct current, or DC, system, ensure that the conductors for the positive and negative polarities are properly identified and grouped together. Use color-coded conductors or cable markers to identify the polarities. This will help to prevent short circuits, which can be very dangerous. Short circuits can occur when the positive and negative conductors come into contact with each other. This can cause a large current to flow, which can damage the conductors, the equipment, or the power source. Consider using fuses or circuit breakers to protect the DC system from short circuits. These devices will automatically interrupt the current flow if a short circuit occurs. When paralleling conductors, it's important to consider the voltage drop in the circuit. Voltage drop is the decrease in voltage from the source to the load. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, use larger conductors or reduce the length of the circuit. The NEC provides guidelines for voltage drop in branch circuits and feeders. Ensure that the voltage drop in your circuit is within the allowable limits. Use a voltage drop calculator to determine the expected voltage drop in your circuit. These calculators take into account the conductor size, length, current, and voltage. When paralleling conductors, it's also important to consider the impedance of the circuit. Impedance is the total opposition to current flow in an AC circuit. Impedance includes resistance, inductance, and capacitance. Excessive impedance can cause voltage drop and reduced efficiency. To minimize impedance, use conductors with low resistance, inductance, and capacitance. The NEC provides guidelines for impedance in electrical circuits. Ensure that the impedance in your circuit is within the allowable limits. Use an impedance analyzer to measure the impedance of your circuit. These analyzers can measure the resistance, inductance, and capacitance of the circuit. When paralleling conductors, it's also important to consider the harmonics in the electrical system. Harmonics are distortions of the sinusoidal waveform of the AC voltage and current. Harmonics can be caused by nonlinear loads such as electronic equipment, variable frequency drives, and arc furnaces. Harmonics can cause overheating of conductors, transformers, and other electrical equipment. To minimize harmonics, use harmonic filters or reactors. Harmonic filters are devices that block or reduce the flow of harmonic currents. Harmonic reactors are devices that absorb harmonic currents. Use a harmonic analyzer to measure the harmonic content of your electrical system. These analyzers can measure the amplitude and frequency of each harmonic. Regularly inspect the paralleled conductors for signs of damage or deterioration. Look for cracks, abrasions, or discoloration of the insulation. Check for loose connections or corrosion. If any damage is found, replace the damaged conductors immediately. Keep the paralleled conductors clean and free from dirt, dust, and moisture. These contaminants can reduce the insulation resistance and increase the risk of electrical breakdown. Use a vacuum cleaner or a damp cloth to clean the conductors. Avoid using harsh chemicals or solvents, as these can damage the insulation. Regularly test the insulation resistance of the paralleled conductors. Insulation resistance is a measure of the ability of the insulation to prevent current leakage. Low insulation resistance indicates that the insulation is deteriorating and needs to be replaced. Use an insulation resistance tester, also known as a megometer, to measure the insulation resistance. These testers apply a high voltage to the conductors and measure the leakage current. The insulation resistance should be above a minimum value specified by the NEC or other applicable standards. When paralleling conductors, consider using a cable management system to organize and support the conductors. Cable management systems can help to prevent tangling, kinking, and abrasion of the conductors. They can also make it easier to inspect and maintain the conductors. Common types of cable management systems include cable trays, cable ladders, and cable ducts. When selecting a cable management system, consider the size and weight of the conductors, the environment in which they will be installed, and the ease of installation and maintenance. When paralleling conductors in a hazardous location such as a refinery or chemical plant, ensure that the conductors are suitable for the environment. Hazardous locations are classified based on the type of hazardous material that is present and the likelihood of an explosion or fire. The NEC specifies the types of wiring methods that are permitted in hazardous locations. These wiring methods include rigid metal conduit, electrical metallic tubing or IMT, and cable types such as MC cable and TC cable. Ensure that all electrical equipment in a hazardous location is approved for use in that location. Approved equipment is designed to prevent explosions or fires. Regularly inspect the electrical equipment in a hazardous location for signs of damage or deterioration. Report any damage to the appropriate personnel. When paralleling conductors in a corrosive environment such as a coastal area or a chemical plant, ensure that the conductors are protected from corrosion. Corrosion can damage the conductors and reduce their current carrying capacity. Use corrosion-resistant conductors, such as copper or aluminum conductors with a protective coating. Protect the conductors from moisture and chemicals. Use sealants or coatings to prevent moisture from entering the conductors. Regularly inspect the conductors for signs of corrosion. Replace any corroded conductors immediately. When paralleling conductors in an underground installation, ensure that the conductors are protected from moisture, mechanical damage, and soil corrosion. Use underground rated conductors, such as use or XLP conductors. Install the conductors in a conduit or duct system. Backfill the trench with suitable material, such as sand or gravel. Mark the location of the underground conductors with warning tape or signs. When paralleling conductors in an overhead installation, ensure that the conductors are properly supported and protected from the elements. Use overhead-rated conductors, such as AXA or AC conductors. Support the conductors with insulators and hardware that are designed for overhead installations. Protect the conductors from wind, ice, and lightning. Regularly inspect the conductors for signs of damage or deterioration. When paralleling conductors, it is important to document the installation. Keep a record of the conductor size, type, and length. Note the location of the conductors and the overcurrent protection devices. Maintain a wiring diagram of the circuit. This documentation will be helpful for future maintenance and troubleshooting. When paralleling conductors, it is important to train personnel on the proper procedures for installation, maintenance, and troubleshooting. Training should include topics such as conductor selection, termination methods, overcurrent protection, and safety precautions. Ensure that personnel are qualified to perform the tasks that they are assigned. Regularly review and update the training program. When paralleling conductors, it is important to follow all applicable codes and standards. These codes and standards are designed to ensure the safety and reliability of electrical systems. Consult the NEC and other relevant codes and standards for specific requirements. Stay up to date on the latest changes to the codes and standards. When paralleling conductors, it is important to use high-quality materials and equipment. Low-quality materials and equipment can lead to premature failure and increased maintenance costs. Choose materials and equipment that are designed for the application. Purchase materials and equipment from reputable suppliers. When paralleling conductors, it is important to plan the installation carefully. Develop a detailed plan that includes the conductor routing, termination methods, and overcurrent protection. Consider the environmental conditions and the potential hazards. Obtain all necessary permits and approvals. When paralleling conductors, it is important to perform a thorough inspection after the installation is complete. Check for loose connections, damaged conductors, and improper grounding. Verify that the overcurrent protection devices are properly sized and installed. Test the circuit to ensure that it is functioning properly. Paralleling conductors, when executed correctly, offers a practical solution for increasing current carrying capacity in electrical systems. Always prioritize safety, adherence to codes, and meticulous planning throughout the process.